Okay, hello everyone. I welcome to all in our lecture series on fiber optics. In this lecture series, we are discussing these topics, which are most essential for B.sc, B.Tech, M.sc, M.Tech, and various entrance examinations. Last class, we discussed important numerical based on acceptance angle and numerical aperture. In this class, we are going to discuss skip distance and number of total internal reflections and corresponding numerical. Okay, so let us start. These things already we discussed in our previous classes. So I suggest to all of you that before you are going to watch this video, you just refer the previous videos. Okay. Last class we discussed these numericals. In this class, we are going to discuss skip distance and number of total internal reflections. Here, we have to calculate the number of total internal reflections that a light ray undergoes as it travels through a optical fiber of length L. Suppose this is the optical fiber and its length, total length is your capital L, right? Light enters from this end and coming out from this end. So in between that, how many numbers of total internal reflections that we have to calculate? Here you can see one reflection, another total internal reflections, and so on. So how many total number of internal reflections that we are going to calculate when the light ray enters at one end and coming out from another end. Okay, for that, first we have to find out skip distance. Here is the definition of the skip distance. Skip distance is nothing but the distance between two successive reflections of the ray inside the core. Two successive internal reflections. So this is your one internal reflection, this is another internal reflection. So in between that, this distance is called as your ls, a small ls. S for skip distance. Here you can see at B, one internal reflection happens. Before next internal reflection, the light skipped the distance or jumped, you can say, jumped the distance, how much? Ls, or skip the distance ls. This distance is called as your skip distance. Okay. To calculate the number of total internal reflections happens inside the fiber, first we have to calculate skip distance, then we are going to go for the number of total internal reflections. To calculate the skip distance, here we considered A be the radius of the fiber. In the figure here, this distance B to D is the radius of the core, and B here from this point to this point is the diameter. So obviously B to D is the radius of the fiber or the core. We considered as A. Let a light ray be incident on one end of the fiber at an angle theta 1. Here theta 1 is the incident angle, theta 2 is the refracted angle inside the core. Theta 2 is the refracted angle. From the figure, the ray undergoes the first reflection at B. So this is the first internal reflection. The second internal reflection happens at F. So here this angle is your 90 degree, this angle also 90 degree. If this angle is theta 2, this angle theta 2, so obviously this angle will be also theta 2, right? If this angle is theta 2, this angle also theta 2. Okay. From figure, the distance AC equal to D equal to LS. See, from this point to this point, A to C, this distance is LS, skip distance, or you can consider this one D to E. Here this point D to E, this much distance is your LS. See, already we discussed between two successive reflection, the distance is your skip distance. That means from B point to D point, this one D point to E point, the distance is nothing but ls, that is your skip distance. Also from this figure, also we can found this much distance A to C also is your skip distance. How? Here you can see, if this distance is your theta 2, this is your angle 90 degree, and this is your theta 2 also, and this is your 90-degree angle. That means this distance D to C equal to C to E. This distance, this much distance equal to this much distance. So if D to E distance is your LS, so D to C will be equal to LS by 2, C to E also LS by 2, right? Now if D to C is your LS by 2 and this angle theta 2, this angle also theta 2, this is your 90 degrees, so obviously A to D is also LS by 2. So here we found A to C distance, this distance A to C distance is your skip distance, that is your LS, and D to E also LS, that is your skip distance. So anyone can calculate the LS or LS by 2 by considering any triangle, this triangle, this triangle, or this triangle. The answer will be same, because this is your theta by 2, this is also, sorry, this is your theta 2, this is your also theta 2, this is also theta 2, 90 degree, this is 90 degree, this is 90 degree. So this distance from A to D LS by 2, D to C LS by 2, C to E LS by 2. So A to C, this distance is your skip distance, D to E also skip distance. So in our derivation, I considered the triangle ABD. ABD. This triangle I have been considered for our calculation. Okay. So same thing I have been written. From the figure, it can be found that AD equal to DC, AD equal to DC equal to LS by 2, or you can write SC by 2, A to C by 2, or DC is nothing but D to E, D to E by 2, or LS by 2. BD, this distance is your radius of the core, we considered as A. Angle BAD, this angle BAD angle theta 2 is equal to BCD also, BCD theta 2, even if ACE, this angle also theta 2, what we discussed. For our calculation, we considered triangle ABD, this triangle. Someone can consider this triangle also. Considering right angle triangle ABD, tan theta 2 will be equal to BD, this distance, by this distance AD, BD by AD. BD is nothing but the radius A, AD is nothing but LS by 2. That implies LS, we found 2A by tan theta 2. 2A is nothing but diameter, D by tan theta 2. This D is nothing but diameter of the core. LS represents the skip distance. Okay, if I am going to represent in the form of sin theta and cos theta, so it will be 2A. D or 2A, 2A we can write 2A into cos theta by tan theta 2 is your sin theta by cos theta, so obviously cos theta 2 by sin theta 2. You just remember this expression or formula for your numerical. Now we are going to write this LS, skip distance, in the form of theta 1 here. This expression in the form of theta 2 refracted angle. Suppose in the numerical it is given theta 1, then what will be the expression for skip distance? Here we found this one, this expression. Just take the square both the side. LS square will be equal to 2A square cos square theta 2 by sin square theta 2. Cos square theta 2 is nothing but your 1 minus sin square theta 2 by sin square theta 2. Here sin square theta 2 divided with 1 and this sin square theta 2 itself, so it will be 1 by sin square theta 2 minus 1, right? Sin square theta 2, here sin theta 2, instead of sin theta 2 I substituted this value n0 by n1 into sin theta 1. This expression we found at the time of when we discussed the acceptance angle. Here I'm going to show you. Here you can see, here you can check this video itself. The video is your calculation of acceptance angle. Here we discussed by applying Snell's law, what we found here, sin I by sin R, if this is your incident angle and this is the refracted angle, will be equal to n1 by n0, right? So that implies here sin theta I will be equal to n1 by n0 into sin theta R. In our case, this theta I written as theta 1, theta R written as theta 2. So this expression will be written sin theta 1 will be equal to n1 by n2 into sin theta 2. So obviously sin theta 2 will be equal to n0 by n1 into sin theta 1. So here n0 is nothing but refractive index of the medium from which the light incidents on the face of this fiber. So this expression we are going to use there. Okay, sin theta 2, instead of sin theta 2 we have to use n0 by n1 into sin theta 1. Here same I have been used n0 by n1 into sin theta 1. Whole square is there, whole square minus 1. That implies LS square will be equal to here n1 will be moved to the numerator, so we can write n1 by n0 sin theta 1 whole square minus 1. That implies LS will be root over of whole RHS part. So here square is there, so it will be 2a and whole root over of this term n1 by n0 sin theta 1 square minus 1 whole to the power 1 by 2. Okay, so here we found LS in the form of sin theta 1. n1 is not here refractive index of the core, 2a is the diameter of the core. So suppose these values are given, you have to just substitute the values and you can found LS. Suppose theta 2 given, so direct you use this formula to find the LS, skip distance. Now we are going to go for total internal reflection. How much numbers of total internal reflections the light happens inside the core to propagate from one end to another end. Here for each reflection, see this is the reflection, first reflection. Before second reflection it travels the distance LS, skip distance, this much distance. So for one reflection or the distance between two successive reflection, we found the distance the light jumped or skipped LS. Or you can say for one internal reflection, light travels or skip the distance LS. So if the total distance or the total length of the fiber is L, then how many numbers of total internal reflection will be? So total internal reflections N will be equal to total length by skip distance. Simple. L, capital L by LS. L by LS value I just substituted over here. You just remember this expression LS, this expression number of total internal reflections, and this expression 2a by tan theta 2. Okay, so this is the derivation of skip distance and total number of internal reflection. Now we are going to go for a simple numerical based upon this. Here question given that an optical fiber is 2 meter long, that means it is given that capital L value, the diameter 20 micrometer, that means 2a value given. If a ray light is incident on one end of the fiber at an angle 40 degree, that means theta 1 given, theta 1. Okay, this one given. How many reflections does it undergo before emerging from the other end? That means n we have to calculate. Refractive index of fiber given 1.3, n1 given. Here you can see at A the light refracted with an angle theta 2. So by applying Snell's law, sin theta 1 by sin theta 2 will be equal to, here this is the refractive index of the fiber or core and this is the medium. n1 by n naught. So that implies sin theta 2 will be equal to n naught by n1 into sin theta 1. N naught always is the medium or nothing but your air. So its refractive index will be 1. N1 given 1.3 here. Sin 40 degree, theta 1 given 40 degree, and we can found theta 2 equal to 29.6 degree. Now skip distance, to calculate the skip distance I consider this formula 2a by tan theta 2. So 2a by tan theta 2, 2a is nothing but diameter given 20 micrometer here, 20 micrometer, 20 into 10 to the minus 6 by tan theta 2, here we calculated 29.6. Finally we found Ls equal to 3.52 into 10 to the minus 5 meter. Now total number of reflections, how much? Total length L given 2 meter by skip distance, this is your 3.52 into 10 to the minus 5. So this is the number represents the total internal reflections happens inside the cable before it has to emerge from this end. Okay, this numerical also you can calculate by using this formula direct, by using this formula L given 2a given n1 given 1.3, theta 1 also given 40 degree. Just use this formula, this one here, this one we calculated, no, this one here, this one, this formula you can use, directly you can found this answer. Okay, by this way or this way you can calculate the value n as your wish. Okay, here I am going to stop this uh, lecture. Next lecture we are going to discuss classification of optical fibers. Okay, thank you so much for watching this video. Thank you.